Welcome to a course on sequence and series. In this lecture, we are going to see a theorem based on the subsequential limit. Let us get into the theorem. Here, you may see the statement and it states the subsequential limit of this Pn. Okay, we don't know how many subsequential limit we are going to have for the sequence, but we are going to collect all those all those limits inside a set, and we are going to prove that set is a closed subset of this metric space X. Okay, what is this metric space? This is the space in which we have taken a sequence, right? Let us start the proof formally. Okay, let me denote E star be the set of subsequential limits. Here I am taking E star to be the set of subsequential limits of the sequence Pn. Right? Now I have to prove this is a closed subset of X. In order to prove a set is closed, what should we prove? We have to prove every limit point is a point of the set. Right? So here we are about to prove E star is closed, that is every limit point is a point of E star. Okay, let me choose I don't know whether this Q is a member of E star or not. Okay, I am taking Q as the Q as one of the limit point of this set. Okay, Q be a limit point of E star. Okay, when once I choose E star, next I am going to choose some n1 such that Pn1, that is a member in the sequence, is not same as that of Q. Okay, where do we choose this P1? It is in this sequence only. So if we want to say this is all those things, it is not necessary. We are choosing a point from a sequence and it is not same as that of Q. Okay. Now you will have to notice, what if such n1 does not exist? Okay, if no such n1 exists, what happens? Which means what? You have to think a little, right? Here we have taken this E star to be the collection of subsequential limits, and we are choosing a point which is a limit point of this set, and we are after choosing that limit point, we are trying to identify some n1 such that this element is not same as that of Q. If it has to be there, what? The set E must have more than one point. If no such Pn1 exists, this means what? E star has only one point. Okay. When a set has only one point, what does it mean? It is a finite set and a singleton, right? Hence, E star is closed. Okay. So in this case, it is closed. Now, when we have this thing, then our construction can be proceeded, right? Next, we are going to choose n1, n2, till ni minus 1 we are choosing. Okay, and we are going to take delta to be the distance of Q comma Pni. Okay, so this is what we are doing. And here, what is the assumption that we have taken? Q is a limit point. Okay, Q is a limit point of E star, implies there exists some X in E star such that d of x comma q is less than some whatsoever the neighborhood that we take, it is going to be true. Okay, and for that neighborhood we may choose any value as a radius. Here what am I doing is that I am doing 2 power minus I times of delta to be my radius. Okay, for this radius, delta is some positive quantity. Okay, I am choosing 2 power minus I delta. This is the random radius that I take. Okay, for this radius, some point of the set will exist in the neighborhood. That is what I am taking as x. Okay, now I will have to see few more things. Okay, for which now I will consider this E I choose. Okay, now what I have is x is a member of E star. When x is a member of E star, it means what? It is one of the subsequential limit, right? When this is a subsequential limit, this x is going to be a subsequential limit for some subsequence, right? It is going to be the limit of some subsequence. I have to identify such subsequence. Okay, for which I am giving this notation, and this epsilon I may choose anything, right? I am choosing the same value as my epsilon value. When I choose this as my epsilon value, I am able to identify a stage. Okay, this for ni bigger than ni minus 1. Okay, after this stage, till this we have seen what is going on. Okay, after this stage what is happening, that is what we are seeing now. Okay, this is happening to be true. Now consider d of we are just going to combine these things, p ni comma q, right? So using triangle inequality, this is p ni comma x plus d of x comma q, and this is going to be 2 times this one plus this one. So when you add, you have the same quantity twice, so you will have to multiply 2 with this, so it becomes 2 power minus I minus 1 times delta. Okay, and finally what you have? You have d of p ni comma q is less than 2 power minus I plus 1. I may write it as I plus 1 as well times delta. Okay, and this is for what? Ni bigger than ni minus 1. After this stage, this is happening, which means what? Whenever this is some this is a negligible quantity, this is also some negligible quantity. This proves, okay, let me write here. Okay, this proves for this subsequence, this is also a limit. That is what it is. It means, right? So this means what? Your Q is also a member of A star, right? We started with a random point, which is a limit point of this set, and finally we proved that is also a member of this set. Hence, E star is closed. And this completes the proof. Thank you for watching.